Alright, so today we're talking about our cross bridge cycling. So this is our cross bridge. It has our actin binding sites at the top, our ATP binding sites right here on the sides, and then our light chains. And these are our heavy chains. And this is on our myosin, because remember over here we have our actin, which is our thin filament that has our tropomyosin and troponin blocking those binding sites. So this is our big slide here. So we have our steps over here, but I'm going to walk through each one kind of. So if we start over here, we can say that this is our energized cross bridge when it has ADP. That means that our ATP is already hydrolyzed. So that means that it's went from ATP to ADP. So this is energized, as it says over here, and it is ready to go. So now we have our calcium plus concentration rise. When that concentration rises, it allows to bind to that thin filament.
And specifically on that thin filament for our actin, our calcium binds to that troponin. So we see that our actin has two sites. This is where our calcium is binding right there, that troponin.
Actin move the heads out of the way so that it can bind, and that allows our globular head to bind to our thin filament. So thick plus thin filament bind. So then down here we have our ADP released from our bond. So ADP released. And once that is released, it causes a shift. So that's also called the power stroke. And that's where that head we see up here, it's straight right here, and then down here it flips. And when it has that power stroke, that is what does the actual, contraction and sliding of the filaments. Think of power stroke with your hand, move your hand, and you're gonna move through the water. So that's what's called our power stroke. So if we follow this arrow down here, we have our ATP again, and our ATP is going to bind to our myosin. Now, once it binds to our myosin right here, it's going to cause it to detach. So, detachment. So, it causes our bridges to detach. And then up here, we follow this arrow. This has hydrolysis of our ATP. So we're going to get our ADP back, and that's going to energize the cross bridge. And we'll be right where we started at the beginning. Now, if we follow this arrow down here, no ATP. If there's no ATP in the body, or let's say after death, then it's going to cause something called rigor mortis, or the lack of movement in the muscles. So lack of sliding, you could say. And that's because they're going to stay contracted, basically. And this is because no ATP. And if there's no ATP, then there's going to be no detachment. So that's just an important thing to know as well, that if there's no ATP available or in the body, then it's going to stay contracted. And yeah, this is our cross bridge cycling.